Okay. This is probably one speaker video, and what I'm going to do first is I'm going to use a speaker. What I have is 31.0042, and this number is pretty accurate. The only part of the uncertainty of this number is the last digit. We can't get it because of things like air, anything pressing onto here, any kind of weight that could alter the mass of my beaker. Okay? So now that I have my mass of my beaker, I'm going to pour some solution in my beaker. Get back in here. First I'm going to repair it. Okay. Use the beaker in here. And now I'm going to take the mass of my beaker with the solution. And it is 60.292. So now what I'm going to do is subtract 60.2920 minus 31.0042, and I'll use my calculator to subtract it, but that is going to be my mass in milliliters of my solution. We want to do that just because we want to subtract the mass, because retearing it after each time can be uncertain, because somebody can come by or something while we're getting the solution. And it is important that we need to be consistent with the same balance every time. Other balances could have a chip or something that could alter our weight of our solution. That's it.
Measuring with beakers, first thing you need to do is weigh it. I'm going to close it first and make sure it's zeroed in. It's 0. I'm going to open it, set our empty beaker in there, and record the mass at 30.936. This will be our constant that we subtract when we get our liquid measurements. Now we're going to pour in a certain amount, and this measurement will be measured to the nearest whole number. Poured in 19 milliliters. Set that in there. And it's 46.6. So I'm going to subtract 30.936 from 46.68. And the mass is 15.744. Our volume was 19 milliliters. That's it.
Today I'm going to show you how to use the balance properly. First off, with the balance, you want to turn it on and then pair it to 0. And then once you do that, you can weigh your beaker. And we're going to be finding the weight of the beaker with and without a liquid. So first thing you do is open the door and find the weight of the beaker alone. And that's going to be, and record your answer. And when you're finding the weight of a balance, there's always an amount of uncertainty, and that lies in like the last digit on the balance. So the thousandth place. And also you want to make sure with the balance that you constantly use the exact same one throughout the entire experiment, because like that just ensures complete accuracy because different balances can be different. Also, you want to make sure that there's nothing around the balance because external effects can shift the the readout, sorry. So you want, and then also to ensure that, you want to make sure that there's nothing around the balance and that like the doors are always constantly shut when you're weighing it and certain things like that. And now I'm going to take the weight of the beaker with the liquid in it. And I'm just going to take an eye glance, and this is 50 milliliters of liquid. Alright, this is the final weight. And now I'm going to subtract the initial weight from the final weight. And this gives me the weight of the liquid in the beaker. And this is how you use the balance properly. Going over how to use the balance properly. First, you want to make sure that the doors are shut, that the things that are surrounding the balance are minimal. Being a carrot, 0. And you'll take an empty beaker and place it inside the balance. I'm going to take the weight at 69.09. There lies a bit of uncertainty in the last digit, so just disregard that digit. And you take the beaker out, import the solution into the empty beaker, place it inside the balance, shift the door, and we have 109.31. Then I'm going to take my initial readout and subtract it from the final readout. So that would be 109.31 minus 69.09. And my final answer is 40.23. And then I will according to the same balance, feature accuracy of the weight.